Hello. The volume might be a bit low for now, but it's gonna go up a little bit. I'm finding new music that's from Minecraft, so there's like no problem. Well, maybe there is, but not yet. So anyways, this one looks good too. Let me add it. Wait, actually no, it doesn't. Well, okay. So here we go. Let me just get my chat. Do. Just yeah, that's my voice. No chat. Okay, here we go. Everything should be fine, except the music apparently. Yeah, let's go in time a bit. Yeah, like you can't hear anything. Can you? Okay, now you can. A bit too much actually. Maybe not. I don't know how much you can hear. Oh. Yeah, let's say this is fine, okay. Let's say this is fine. A bit too fine, maybe. So anyways, I wanted to... Basically, I think I got my first comment on a live stream of this series. So I got kind of happy. Thanks a lot to Elsemishi dedicating this stream to you. And yeah, I wanted to show some people because basically I realized that some people might want, might watch the replays, right? And I wanted to give a quick look of the things at the start. So basically we want to generate a donut. As you can see, we generate a donut. We can walk on the donut, right? So like in local space, we can go forward and we are going to loop around the donut. We can also, technically we could destroy. And yeah, basically yeah, I still have an error. Let me just change the pipeline. I guess I'm gonna keep the collision pipeline. I think it's fine if we, if we give like multiple choices to the player, like optimization wise, for example. And yeah, we can basically destroy the cubes, right? And we can go down, and you can see that even though it's a torus, where basically cubes should be converging towards the center, right? It's supposed to become smaller and smaller and turn into rectangles. Well, basically because of my shader, the closer you get to a cube, the more it looks like a cube and not a rectangle. So this is good. And last time, well, we actually, before that, we managed to have some collisions. So this is the collider of my player. Wait, let me generate the collisions. Okay, just gonna remove the previous thing, the previous setting. So yeah, we have colliders that are generated for chunks, and you can see that the colliders are not at the position of the object itself, right? It's not like at the position of the chunk, but it's at the position of... Okay, here we go. Well, I can't move actually with this camera apparently. Maybe it's because wait, actually, I know why. Okay, never mind, I can. Yeah, I can go up, down, but I can't go more down than this because of the collisions, right? And the thing is that this collider, yeah, this collider, this camera and collider, well, the collider is synchronized with this character. So if I go this way a lot, for example, so we're gonna generate chunks, and for now it's, well, colliders, and for now it's really slow. But if we continue, we can switch the camera, and we realize that we moved along the torus, and we can do the same there. I can move this way, and we can realize that the collider also moved along a specific direction. As you can see now, it's like well, it's not a straight path, and now we're here, and we generate chunks around us. So colliders are, for the moment, really slow to generate because we are not, we don't try to merge triangles, but we can basically optimize this a lot because instead of all of those small triangles, we can just generate 2 big triangles, right? To make like a quad. And it's like kind of the same with, well, we actually have those colliders on the edges that we can remove, and, well, the collisions with those triangles that we can remove. And same with meshes, well, same for the chunks. Right now we have some delimitation that we can actually remove. So we're gonna handle that another time. For now, I think I spent a lot of time on optimization because I wanted to be able to break blocks and place blocks pretty fast. And this is what we did last time. Last time I can run the doc, but I realized that I might have to make a debug tool to visualize this faster. Because basically I made a custom render pipeline, but the problem was that I had to, well, open RenderDoc every time, and it was kind of like a problem. So I'm thinking of very quickly create a, how do you call that? I mean, maybe just, I already have this, right? So like UI basically. So this is a cursor. We can say cursor. And I'm just going to create a sub viewport container. And the goal is to simply display the image that we generate with our render path. So if we do this, for example, on the bottom right side of the screen, we should be able to see our texture really soon. Actually, wait, do I really have to do that? Can I just do texture rect? Maybe I can just do this, and we should have, for example, image texture, which should be maybe an image. So in that case, we should be able to set things very easily. So we can have pickup texture. And we can try, well, we can start making some debugging tools. It shouldn't be very long, so I'm just gonna do that first. And the goal this, well, tonight is going to be, wait, let me rename my streams, actually, I forgot. But it's going to be modifying the terrain, placing and removing cubes. Here we go. Yeah, I feel like I'm talking very, well, not loud, let's say. Maybe I'm not, maybe it's just the volume. Okay. Here we go. Let me quickly get a few things. Here we go. Okay, should be good. Okay, so this time we have this, and we have we generate the texture somewhere, but okay, and pick up render pipeline, but I don't have access to it right now, so I'm gonna just give access to the OR IDs. And yeah, so we also have to fix a problem. We actually have a problem in the pipeline. I don't know why this happens, but this seems to happen. So we have all of this. Okay, we have all of the OR IDs, and we should be able to make like getters and setters for all of those. Maybe not all, but at least the ones we actually care about, like the output texture and the depth texture. That way we can debug things. I'm just gonna do that. Get depth or ID. Get, well, set depth or ID. Depth texture. Well, yeah, we can do this. So this is OID. And here we go. We can do the same with the output texture. Get, well, outputs OID. Let's say, yeah. Then we can, well, we have the output texture. So that should be good. And I mean, I think that's mostly only what we want, right? So shader path, shader file. Well, actually, yeah, we're just using what we used before. So we have all of this. Now we can register those variables. So it's gonna be there. We're gonna copy because yeah. Hey, bye. Okay. So then we have the depth texture. That depth texture. Wait. Depth or ID. Then you have the get depth or ID. We can put this here, we can put this here, and we can have well, depth or ID. Right? Yeah. And this is a type of OID. I actually don't know what it is. What is a OID? Let me check inside if we have. I mean, that's something a bit unique. So maybe there, object, OID. Oh, we do have OID here. Good. So we can just replace this OID. That means we can remove this. And it's, you know, we can make it a bit easier to read. So like this in 1.9 is good enough. It's short enough. We can also do that there actually. Boop. And here. Boop. Here we go. So now we can do the same for the color texture. So that's color outputs or ID. Yeah, that's the name. Then you have the gets color or ID. Gets outputs. Get outputs or ID. And this is output or ID. Output texture, but you know. So we have this. I guess we can restart. And yeah, I wanted to know Godot texture sets or ID. You can assign a low-level texture or ID or material using texture 2D or D directly through the rendering server, and set its sprites and set its NNM property to assign a OID created from rendering device to a sprite, and all of this. Okay, yeah, good. But why is that though? Texture 2D or D. Why RD? Texture 2D RD. I mean, RD is already the pipeline I'm using, I think. Texture create. I mean, as long as I set the OID, actually it's good. So it should be fine. Only valid for the current session. Ensures the texture format matches. Using a local rendering device you must share. Yeah, I mean, it should be good. So we have a plan, and the goal is just to display the texture. And after that, we should destroy blocks. So I actually want to check a little what we have, because we are storing IDs basically in a texture right now. Let me show you right away. I'm gonna do that in the process maybe. Maybe not in the process because we create, actually in the process because we can resize the screen. So let's go like here, process. I'm just going to have something like var debug texture and texture. Wow. Control image, actually, it's an image. Yeah, it's an image, my bad. So I should be able to do image.rid. Yeah, that doesn't work. So I'm just gonna go there. We have the texture. So we should be able to do this .text. Maybe not. I'm actually not sure. Direct texture. Oh, I can't drag it in. What is that? It's a texture rect. Oh, my bad. So it's a texture rect, my bad. I just said it. So now we can get the texture. We can set it equal to texture to the RD, I think. That was the name. So text equal texture to the RD. That new. Yeah. And then you have text that texture or the RID equal outputs. Well, it's from the pickup pipeline. That's outputs RID. And now we can set it. And let's do this only if this is null. That way we don't reallocate the texture every time. And we do this. Or maybe actually let's just do this. Let's just do this. And it should be good. Okay, let's try. I hope it's going to work fine. First try. Okay. Yeah, texture. Oh yeah. Yeah, I have to assign it. So we assign. And now we should be able to display or not. With value of type RID on a base object of type image texture. What do you mean? So this doesn't exist. Oh, image texture, that's why. Oh, right. Oh, right, I have to remove this. Okay. Okay, now we have a texture on the top left corner for some reason, apparently. So I actually enabled the collision, so let me just disable the collisions to go a bit faster. And when we left click, it's going to render inside our texture. So like as you can see here, I'm using the pickup pipeline. So I'm gonna try left clicking and we're gonna see what it's gonna do. Boom. That's interesting. Because the texture is not set to, well, it's set to keep size, not ignore size. So let's keep just centered, aspect centered, probably. And this texture is gonna be, yeah, I replaced it. So let me just move it down there with like a size of, you know, like this, kind of. Maybe. I don't know if it's gonna be good or not, or if it's gonna go. Actually, it should be good. So we got there, and now we have the texture. But the texture just sucks. So that's the problem. So what's the problem? Unsupported image format? Yeah, I know. Attempted to use an uninitialized RID. Oh, right, that's at the beginning though. Okay, so I guess I'm gonna have to check a few things. The first one is this. If this is valid, then we're gonna do this. And only if that. So that should remove a lot of errors. And then we have to address... Okay, so it's actually entirely white right now. So it's actually not that bad. Let me close. So pipeline is invalid. Yeah, okay. I had this problem before. I don't really know why it's doing that. Unsupported image format because I only have a red channel. That's the problem. Texture which displays the content of an external buffer. I mean, this one should be nice, 2D RD, but yeah, it seems I can't display it because the format is invalid. I mean, good enough. Maybe I just can't display it. That's fine. What about the depth texture though? Depth or ID? Well, actually I can't because the depth, they're using like a different thing. Yeah, that sucks. Yeah, it's gonna be like that too. Well, and actually it's not even readable. Texture is no. Is it? Wait. Oh. Yeah, I mean, yeah, it's no. Of course it's no. Wait, why is it now? Wait, what? Text is no. If there's one thing that shouldn't be null, it's like this. But unsupported image format, I guess. So okay, that's fine. I'm gonna give up on this. It's not that important anyways. The thing I want though is I want to retrieve blocks and I want to destroy them, and this is the goal for tonight. I want to use my pickup pipeline to do that, and that means we're gonna have to store some IDs and stuff. So we have the customs that push back here, and we push the block index for the moment, but that's not the only thing I want to push. That's not the only thing I want to push. So also right now we push floats, but I actually don't want to push floats. I actually want to push integrals. So because of this, I'm going to fuse things together. I'm going to fuse things together. So I'm going to create a function that's going to be called create object ID, let's say, is gonna be a uint, I guess, like this, and it should actually be a static function. I think there's no reason it shouldn't be. Actually, never mind. Wait. Actually, no, this is probably fine. Is it? So anyway, we have this. I don't know yet, but we're gonna see. So we have this. We're gonna need the block ID, like block index. So this is an int 32 uint. Okay. Then we have the chunk. So I mean, we have it currently, so that's why I wasn't sure whether to make this function static or not. I mean, maybe I can. And then we need the space though. Then we need the space. So let's not make it static. So we have the chunk. Well, let's have an idea for the chunk. So chunk ID. This is 0. Actually, do I want to put the chunk in? I don't think I want that because I can just put it in a uniform. Yeah, and it's like the final texture that's going to have it, probably. Is it? Yeah. Is it? Because if I can store the chunk plus the face and those things in in my output texture, that means I can store it in the input float too. Except if I want to, actually in my final texture, I might want to put more data because I can put multiple channels, but it's not really the case here. Well, I technically can, but it will be like very big. I'm not sure I want this. So unsigned, let's just have the chunk ID for now. We have the block index, so we store the block index. We also want the base index, which corresponds to the buffers we have. Actually not here anymore, but somewhere. Like, where is it? I don't know. Like there, right? Face to indices, that kind of stuff. So we have different faces, and it's like from 0 to 6 for a cube. But basically, it makes it so even if we have a different shape, we can always, put like a different value. This is the goal. We just have to implement this for different chunks. And this is it. So we have this. We have the block, we have the face. And do we need the chunk, really? I really don't think we do. But well. What do you say? What would you say? So basically right now we have the, well, let's say we have a float. So it's 2 power 32. Let's say we want the block index. So in a chunk of 50 times 50 times 50, 50 cube, that means it's removing all of those possibilities. So we still have all of this. And then we have faces, so we don't divide by 6. We go back. And we multiply this by 6 for each face. And this still gives us a lot, basically. We still have a lot with this. So that means we can still encode a lot more things. We can encode, for example, a bit for whether it's an entity, for whether it's a block, for whether it's that kind of stuff. And yeah, we have a lot of things we can do. We have like 32 bits. That's a lot. So, oh, boo. So. I mean, we have different possibilities, but we do want things to be split very easily, right? So I'm gonna first do something like this byte. We're gonna return the byte. And now we're gonna, actually, do I want, yeah, let's make a float. This is gonna be a float. And we're gonna just reinterpret this. So we're gonna cast it into a float. So basically if you convert an int into a float by default, like for example, if you do this, it's going to try to convert the value, not to the memory layout. And I want to keep the memory layout. Well, I want to keep the memory. So I'm gonna use a reinterpret cast, casting to a float star, to a pointer to a float. And then we can dereference it. So then we copy a float instead when we return the float. Well, actually there's like return value optimization. So it's not really a copy, but yeah. Then we have the byte. And the byte is going to be, I think it's going to be pretty simple at first. Let me think. Because the block index, so basically it should be the bits on the right side, right? Because there's like different endians, like the big endian and the small endian. Big versus small endian. Well, C++ maybe? Is C++ using big or small? I think it's like depending on the computer though. So it's not about C++. Yep. That is the native endianness of the CPU architecture. I mean, it doesn't really matter though, right? It doesn't. Well, actually, I want it. It matters because I wanted to do a plus, but block index. Let's have. So first, let's verify that something is cond. Let's verify that the block index is valid, and we're gonna do that by having some cache. So these are bytes. For example, this one is 255, and then this one is what is it? F. So 10, like 16, I guess. It's 16. And you know, it's like multiplying by 16 every time because it's in hexadecimals, right? Like hexa 16. So we have this, and if this is different than 0, then that means it's true. And that means it's not good. Expected an expression. Yeah, don't worry. So here we go. So basically what we do is we ensure that this is like this. Well, like this. So this is like my integer, my whole integer. And we have the 4 last bytes that should be this. And this index should not be bigger than that. So I'm gonna... Wait a second. I just realized, but... Wait, it's not working? Oh, it is? Okay, never mind. Yeah, okay, this is fine. Good. So yeah, we have bytes. So 4 bytes. 4 bytes. No, 2 bytes. This is 2 bytes. So 2 bytes, how much is it? 1 byte is 8 bits. So this is like 2 power 16. So we have all of those potential values. But if we do, for example, this times this times this, we realize that it's actually too small, right? We don't have enough values. So we're going to allocate a bit more. For example, we are going to allocate all of this. And now, that means we have 16 more values. 16, no, not 16, 24 in total. Wait, is it? Wait, am I completely wrong? Yeah, I am. It's 20 actually. Because 16 times 1, 2, 3, 4, 5. Wait. So that's like 80? Wait. Am I stupid? Wait, 1, 2, 3, 4, 5. So I mean it's like 2 power this times 16. That's not what it is. Plus, wait. Oh boy. Wait, something is definitely wrong. So by default it's 32. Right? It's an integer. So it should be 20. 16, but we get 1. Wait, that's 4. Wait, that's... Am I... 1, 2, 3. Wait. We have 1, 2, 3, and 4. So we have 4 bytes in total. Oh, right, that's a bit. That's why. Yeah, my bad. So 4 bytes. That's like 8 divisions. of 8. So we have 5 times, wait, 5 times 8? That's, am I stupid? Wait, wait. Yeah, I think it's just 20 anyways. So we have all of this. We're just gonna remove 50 times 50 times 50 times 6 for the faces. And now we can see that we have enough values. And we can actually continue this way for a bit more. We can, for example, go back there. Instead of, well, how many times can we allocate this? Let's try this. If we allocate this 1, well, actually it's 4, then it's 8. So what if we double each side? We can still do that. So we can have like a 100 times 100. Well, actually, I don't have the 6 anymore. This. Okay, no, we can't. So yeah, basically my chunks should be less than 100, 100, 100. But that should be fine, right? That should never be the case, really. And even if we have something similar to that, it's never gonna actually be the, well, actually, is it? Never mind. Yeah, it's the index. Okay. Anyway, that's fine. Let's go with this. Or do we? Wait. 256, because then we have to encode the chunk or the space. Or maybe we want to encode the space, actually. I mean, there shouldn't be a lot of spaces, and especially at the same place. But block index, face index, and we can also have, well, I mean, the block really is the most important. So I'm not sure about the other things, but we can have I mean, okay, how much is that? It's like 12 to power 12. It's like all of this. So that means we can have that many chunks. Is it a lot? Like if I do, well, I mean, 10 per 10 per 10. So if we have 10 chunks in every direction, it looks like this. So this is actually like very small. Okay, now I'm a bit, I'm actually not sure. Maybe I want another channel. Yeah, that's not a lot. That's definitely not a lot. Like if I just double this and like this, we're already reaching the limit. So that means we won't have enough chunks at all. I want a lot more chunks. Well, actually, I only care about the chunks that are near the player, right? So maybe it's fine, because I will never... Will I? Because that's basically for the click. Yeah, maybe I don't need that many chunks. For the pickup, specifically. Because I can always discard the chunks that are behind me too. Right. Can I? Actually, I can't. Because there's a transformation. So I don't know what's behind me, necessarily. So... yeah, this is a lot smaller than I expected, actually. I'm not sure about this. Wow. Let's do this minus this. So minus. Let me just check this again. If we do times 6, right? Yeah, I guess I can just do the end. I don't need to split it per byte, for example. I'm just gonna try, I'm just gonna see something. I'm just gonna go to 100 to be sure. And these are the possibilities, well, that are left. So this is still a lot, right? So wait, that's crazy. I have all of those possibilities. Wait, something was wrong. I don't know how I computed things, but something was wrong. But we have this. So then we have block index. Maybe we... Yeah, what is that actually? It's this. So it's like really small actually, compared to all of this. So wait, why did I compute things wrong? I think I was using the... I did math wrong. I'm just very bad at math. Got it. So... You know what? Let me create a graph. So we have, in binary, we have 1, 2, 3, 4, 5, 6, 7, 8. This is 1 byte. Then we have this, this, and this. Like this, basically. Can I just split? Can I just do this? I want to split the bytes. Make it easier to understand. And I'm just gonna... This looks so bad. Is it even working? It's not working at all. What about if I make a macro? Make in 32. So we have A, B, C, D, and we're going to return A, B, C, D. Can I put them together? Like this? Is it gonna work? This... Actually, it's... Well, we have this, we have this, we have this, and you have this. Okay, so this should be good. This is my int 32 divided in bits this time. Wait, 16. No, that's wrong, is it? Is it? 8. 32 you divide by 4, it's 8. Yeah, it's good. So then you have this one. Should be... So yeah, I said that this was not enough. But when I do 2 power 16, yeah, this is definitely not enough. Right. So we're gonna do 12. And I was trying to do like this. Times 6. Yeah, the times 6 is a bit too much, so... Yeah, there is a problem. Oh, no, I get it. It was because of the combinations. Right, the combinations. So I mean, 24 is definitely good. And that leaves us with only 1 byte. 1 byte is 255. And I mean, I might have like a bit for whether a hit is detected or not. Yeah, I guess the first bit is about whether it's detected or not. So we're gonna have this equal 0. U. We are gonna have I mean the last byte is always gonna be like first you could say first byte is reserved for whether. Oh, actually that's a good thing because it's actually not. Wait. Is it? Because for the input vertex, we actually don't need it. It's only for the output that we need the hit. So we can actually store additional information there. But what would it be used for if I can't add it in like the output? Let's just say first byte is reserved for whether an object is hit or not. Let's just do this for the moment, and we're just going to test that we have. Wait, which one was it? F? Like this? Wait. So, like this. 2, 2, 2. Like this. And F. Yeah, let me just check this, but maybe it's not good. It might be the. Yeah, that's not gonna be good. Wait, 1. Right, never mind. That's supposed to be a 1. Like exact to integer. Let me just check this. So if I do 0, well, 0x1, like this, is going to be out of this. So this should be good. And if I have a F, that should be 11. Well, actually, no. What? Decimal. Binary number. Okay, that's the binary that matters. So yeah, these are 1s, and this is just 1. So let me just add this one. Let me just have this one. First bit is reserved for whether an object is hit or not. Then we have the... Which ones? Actually, I guess we can have this here, but well. Anyway, okay. We can have all of those bytes, then we can have those ones. So it's like 2 power 1, 2, 3, 4, 5, 6, 7. So it's like 128 because it's 256 divided by 2. By 2. That's not a good amount of chunks. Yeah, wait a second. Yeah, I mean, I just, well, I do want this in the end. Oh yeah, but I have like an additional bit for that, for chunks actually. In the output texture, I mean, because of the hit potentially. Creates object ID. Well, create inputs object ID maybe. Well, create pickup input object ID. That's going to be very specific. That's fine. That means we can potentially have operations in the shader to unpack this. I don't really want operations to unpack. So yeah, let's do pack pickup object ID. And we are going to have the hit value. By default, that is going to be I mean, I guess it's gonna be 1 actually. So this. And this. Like this. We ensure that there is a 1. That wasn't set before. And actually we can just bit shift 1. Well, what? Yeah, I don't know what I'm saying. Faces. Okay, in any case, let's encode the face. Let's encode things. I guess I really don't know for the chunk. We might have RNG. Yeah, but for the output texture. Yeah, so that means okay. Like pickup input object ID. Okay, we're gonna have some operations in the shader, I guess. But that's fine. So let's say we have all of this. This should not be true. But then we have the unpack function. And the unpack is gonna be something. Unpack. We're gonna get a float as an input. Maybe like this. Object ID. And we're gonna return all of this. Right. And potentially the chunk ID, maybe. Wait, unpack, right, like there. So okay, we have this. So now we can, let's do is hit. Is hit is whether, well actually let's print up, right? Object ID, we're gonna have the byte that is gonna be equal to the reinterpret cast of 32, like this. We cast and we can just make a copy, that's fine. That's gonna be constant. Is it? I guess it is. So then we check if this is hit, and we check this if the first bit is set. Yeah, I guess we're gonna do that first, because the output texture is gonna be a single channel. Is it? No, actually, maybe not. Anyways, so we have this. Then that means we have... What do we have? ABCD E, EF. We have up to EF. So 0xEF. Like this. For the chunk. Like we have maybe chunk ID. Well, actually, we already have it. Equal this. So if we check quickly with Google, there, we can see that this is 1 here, but this is actually just wrong. Wait, EF convert. Wait, this is actually totally wrong. Yeah, okay, this is actually completely wrong. So F, E? No. Yeah, it's the last one. So it's like minus the first... pain. How do I do? I mean, I guess I can just do the operation. I'm just gonna say that this is the first byte without, so with the end, with the end, yeah, with the end, this is the opposite, and we can compute that. Basically, the compiler is going to be able to compute that during compilation time. Well, compute that during the compilation time because it's already known, it's like a constant. So we just remove this. Can I do an AND? If I do an AND, it's only going to keep the bits. If I do an OR, it's going to add both. If I do XOR, it's not going to have what I want. So yeah, it should be like this. Yeah. So here we go. We have the chunk ID. And actually we should move it to the right, because that's gonna be a big ID. That's gonna be a big ID if we keep it like there. It's like move by 24, I guess. Like this. I mean, I guess we can do that first, actually. Let's keep things like this. So we have the chunk ID. That should be a uint 8, really. So like that's not a lot, but that's how it is, I guess. Then we have the... Yeah, what was the face? So for the face, we can have... How much is not an octagon, it's an hexagon shape. Tessellation. I don't remember. It's like a honeycomb shape tessellation. Really? So how many shape? Well, how many honey? Let me tessellation. How many faces has a honeycomb in shape in pretty? And we can see that it has 9 faces. It's like up, bottom, 1, 2, 3. Wait, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, a 3D cube cell has 6. This is 9. This one is, wait. Wait a second. So let me ask another question. Tessellation field-based shape, maybe? Regular shapes, actually. So we have this one and 3D. Like regular shapes. So we have all of this hexagonal. We have this one, where every face is a rhombus. We have this one. I didn't even know about those. But that makes sense, though. That's funny. 3D equivalence. Space filling polyhedra. Yeah, I didn't know about those. But that's kind of funny. So 12. And this one has 6 and 6. Because it's not the same shape in every direction. So I mean it's like 12 in total. I might reserve like 16 for faces, but it shouldn't be that big. 16 is actually a lot. Wait, 12? Wait a second. I mean, 12 is already a lot, right? So let's go with 12. 12 is... How many? Actually, already too much. So I guess it's gonna be 16. So 16 is like 1 byte. 1 full byte for that. Wait a second. No, that's not a byte. Wait. Am I stupid? No, okay, it's 16 values, not in bits. So this is 4 bits. We can have 2 power 4. That gives 16. So it's 4 bits. So we're gonna reserve 4 bits there. And you're gonna have this base index like this. And this is gonna be equal to so instead we want 4 bits. So f divided by 2, like 8. F divided by 2, yeah, sure. Here we go. And that should be the only thing there. Right? And then we can do this. So if we check with the converter, this is good. Right? This is starting with a 1. Wait, is it? Why is it good? Wait a second. That's not good. That's not good at all because I want multiple... you know what? Let me... Can I modify this? I can't. That sucks. You know what? Let's do the opposite. Let's go integer... How is it called? Bits to example. A. So binary. Okay. We can do this, but we can also do this. That's kind of the same, is it? But yeah, let's say we have this just to test. Wait, this is only... Wait. 4. Right. Wait, this is 8. Okay, I need more. 8. 8. 8. I need these spaces. Really? Can I just do this? Exact results. Wait, is that the same? No, it's like dividing. What? What? I'm... Huh. Interesting. I mean, I'm gonna make my own program actually, because that's a bit complicated. So I'm gonna go with online CPP. And let's just do stdc out. So, we're gonna have a uint 32, v, and we see out, and v equal 1, 2. Well, actually, we can just make it right, like this. And we can have poof, well, let me actually put 0b here. And this is going to be 1, 2, 3, 4, like this. Okay, so we have all of this. So if we want to check run, well, actually we want it in exile, right? uint32 not declared. Yeah. Let's include std_int. And let's include, I mean, I should have the std_eggs like this. I don't think this is it, but we can try it. std_int. Enable to find operator b. Interesting. Too few arguments. Like this. Okay, seems to be a bit better. But then we have an expansion of macro. Use numeric literals to enable more built-in suffixes. What if I do like this? Const character. Okay. Maybe I got it wrong. Maybe it's actually this if I want to merge them together. Okay, this is it. So we have this. Now I can do this. And now I have this value, which is a value in exile. And as you can see, it is what I got. Wait, that's not what I got there. Wait a second. To 0b, then you have like std ball. I don't think that's gonna be good. std cout show int as bits. Bit set. Like eggs. I guess it's bit set. I mean, technically, I can. I mean, Godot has like a bit set bit field. Yeah, I should probably use this instead. Let me just go inside, please. Please. Bit field. So we have the value. Oh, uint64. Oh. This one is big. And is enum. Static assert. I don't want this though. I don't want to check if this is an enum or not. So never mind. I'm not gonna use this. And we have std bit set of v. I actually can't see like this. Oop. Missing templates argument. What is it supposed to be? 8. 32. So this is the value. So this is converting. Is it converting properly? Let me just check this. Well, 8. To binary. Yeah, this is actually fine. Wait, so I was wrong? Maybe I was just wrong. Yeah, I was probably wrong. Definitely. So wait, if I just check this, let me just check this. Wait. What? That's oh, that's the problem with zeros, right? Because basically it's a question of zeros. It's like very similar, but there's just so many zeros that you don't see the difference. But there should be a difference, and this one should actually be the correct version. And yeah, that probably makes sense. So let's skip this. So this one is the first bit. Wait, that's not what it's supposed to be. Can I just copy this? I can't. Why? Well, paste. Yeah, okay, now I can. Okay. I can't copy the output directly with Control C, seems like. So anyway, we have this. Then we're gonna have the same, but with everything being the opposite there. So this is... I mean, actually, I can just do the make in my code. Yeah, let's just use the make in my code. Yeah, that's kind of stupid of me. I'm just gonna have 0 be this, 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 and this. And this is... Oh, let's remove this. Good. So this is the first bit. Then we have chunk ID is basically gonna be byte and this, but this time we remove the first one and we have those. And now we have all of this for the rest. And 2 power 7, yeah, for the chunk, it's actually very small. It's like very, very small. It's actually, maybe I want like the face instead to fill this hole. So if I have like 4, this is 16 we said. So let's just have 4 maybe. So 1, 2, 3, 4, and the rest is gonna be 0. That way we have the face index there. Okay. Okay. Then we need potentially the chunk index. So the chunk index is going to be... How many values can I have? So 2 power... So 8, 16, 20. Let me check 20 again. If I do this minus 50 times 50 times 50. Actually, yeah. That's still enough. How much can I go for? Like if instead this is like... Can I square cube? Well. Wait, what was it? It's out of this. Let's do... ands. Wait, okay, it's there. So if I do... like square of ands, can I have the square root? The square cube? Oh. Okay. So then we have, okay, this is it. So let's say that this is 2 power. So we want the square cube. of 2 power 20. I mean, I guess I can just remove. So we have this 100. And if we multiply, I'm just gonna ensure. We see that we have just enough. We see that we have just enough to have like a chunk of 100 times 100 times 100, which is like a lot. And I think that that should be like really the maximum we should have. So should be fine. And yeah, we also have the amount of face rendered. Maybe, well, actually, it's not about... Actually, let me think a bit more. Because right now we try to store for every block, but every block is actually not rendered, right? So if I go... And like, not every face either. And I have quad index to cube index. So maybe I want this instead. So if I use this, I should actually have a lot less values and like a lot more possibilities. And that should be a lot better. Quad index. Yeah, quad index. So let's do this. This is actually not the block index. This is not the face index. This is the quad index. And wait, but do I have the normal from that? Quad to cube. Oh yeah, because... Oh no, I don't know. Clear pushback. Okay, so I add it for... No, I don't add it for faces that don't have enable. But I can have another array that has this information. Like for example, quad index to face index. I mean, I definitely wanna store the idea of faces I have, I think. As long as it's 01, it's not that much of a performance issue. If I can reduce the memory, because the memory is gonna be huge. It's gonna be huge. So let's do this. So instead of the face, instead of the block, it's gonna be a quad. Yeah. Quad index. And that way we can store, well, visual quad index. And that way we can store, I mean, a lot of things really. I mean, basically we can just store like the rest. Maybe we want the chunk ID though, but that should be like a lot. So the chunk ID, how many chunks do we need actually? So let's say we want this. Is it going to be enough? Can I split things in some way? I could have something a bit dynamic. Instead of having the object ID be constant, I can have like amount of chunks. That way I can modulo. While I can remove the thing. Something dynamic is, well, something dynamic is probably for the best. Because if we have a lot of chunks, we don't need a lot of faces per chunk. And if we have a lot of faces per chunk, that means we don't need a lot of chunks, right? So let's say we have NB chunks, for example. We have an amount of chunks. That means we can modulo things out. That means we can do the AND. Because that's basically if I do byte and NB chunk, that should return the amount of well, the ID of the chunk, right? So like chunk ID, technically. So is bitwise and the same as modulo for unsigned int, and it should say no, it's not. Shit. But they produce identical results only when the divisor is a power of 2. Only when it's wait a second. Yeah, so it's like very different. Okay, never mind. I mean, I can have this actually. I can actually, instead of doing binaries and stuff, I can try using... Yeah, I can actually just... Yeah, I don't need this. I don't need this. I don't need this. Because I can just do NB chunks. Let's say we have 100 times 100 times 100 chunks, which is a lot. We do byte. It's not byte. It's like well, bytes. Let's say we do this modulo NB chunks. So we have the ID of the chunk, and then we can do this equal, so divided equal by NB chunks, right? And yeah, we can actually do things pretty easily this way. So we have the chunk. Then we can get the visual quad index for the chunk. So that means I should not update it. Yeah, that's a bit complicated. Is it? Nice. That means I should keep the values of the arrays the same as they were. I'm not sure about that. And maybe for the quad to think it's fine. I don't know. Maybe not. Maybe I can wait for the next frame or something like that to refresh. Yeah, I can actually cache things instead of recreating arrays directly. I can just cache it for the next frame, and that way I can process the pickup before changing the frame. So I actually don't know. I mean, it should take a single frame, right? I actually don't know. Has pickups. Maybe I can start. Well, maybe I can wait for the pickup actually. Okay, so let's do bytes divided. Well, now we have visual quad index equal bytes modulo NB visual quad indices, which should be something, probably. Wait, yeah. So now we can divide again. And then we have other things. I don't know what it's going to be, but I mean, I guess we have the easy hit. Yeah, the easy hit is actually important. So it's gonna be a modulo 2. So like is hit equals bytes modulo 2. So it's like the first bits on the right. And that way, like it works for small endians and big endians, which is good. And if this is different from 0, then there is a hit. If not, then there is no hit. And that also means, well, that means I can do, let's just do a modulo, because I could like make a bitwise operation, but the compiler could optimize this. So this is fine. I can do this. Move it. I'm just gonna divide equal to make it understandable easily. The compiler should optimize this. And like even the equals 0, it should be optimized. So let's just, you know, have like a condition instead of like some kind of cast. If this is 1, but if this is different from 0. Yeah. So is hit, then you have the chunk ID, then you have the this. Wow. Yeah. And how much does that give us? I actually don't know. That should be like pretty good, but... So let's say we have 2 power 32 minus... Wait. So this minus... well, actually it's divided by 2. Is it? Yeah. Divided by 2. Whoa, that's a lot. Then we divide by the amount of chunks. So we divided by 2. Then we divide by the amount of chunks. So maybe this times this times this. Wait a second. Isn't that like a problem? Yeah, that doesn't leave us with a lot of things. Wait, what? Wait, am I stupid? No, I'm good. I should be good. So why is that bullshit? No, that's not bullshit. Yeah, because basically it takes one more... Yeah, this is complicated. Okay, you know what? Let's have an example. So we have this. Let's do, for example, do uint 32 v equal the max. Then we have stdc out of v. Well, let's just have, well, all of this really. Like all of this. We're just gonna copy. Have it here. So we have, well, the amount of bytes left. And visual, let's say we have, 100 is actually crazy. Let me just go to 50 maybe. Oh. 50. And this is like 50 times 50 times 50. Let's try this. Bytes. What's this? chunk ID, right? So this is 0. Wait, it's like, yeah, it's too much basically, because we are dividing too much. So basically it won't be able to, but it's like only the face is visible still. And it's like quads. Oh yeah, I forgot about, it's a quad though. So that's like even worse potentially. Maybe I don't have enough. I don't like that. Maybe this. Yeah, I don't have enough. 30? 30 should be good, right? It's not. Wait, am I doing something wrong? Okay, this should definitely be good. Okay, yeah, there's a 2. Yeah, so wait, what if I do this? 4. 4. Oh, because it's like times 2. Right. That's so tricky. Yeah, so I actually don't have a lot. What should I do about this? I mean, maybe I can just change the texture actually. Maybe I can have like 2 different textures that I run differently, well, depending on like the circumstances. But I guess for now we're gonna be a bit limited. Oh, we. I mean, Uint 64 is actually like the best, probably. Because it works per 8, right? Let me actually check something. Maybe not. All operations on Uint 64 faster than Uint 32. I'm not sure about that because I think yeah, it's like a 64-bit CPU, right? Just as fast. Isn't it like slower? I don't know. Single instruction. Twice as large. It wins because of cache. Yeah, I know. Division can be slower for, oh no, many CPUs have necessarily higher latency for the division. No. If you're vectorizing, I can optimize division, well, the modulo. Oh, this one can actually be faster. Wait. Instead of this. Oh, yeah, because of 2 integrals. Yeah. Fine requires multiple instructions. I mean, if I want to be safe, maybe I want to make a texture a bit bigger, you know? Because this is definitely a bit limiting. Let's check the size of the screen. So we have this. So this is the amount of pixels. And let's say we store 4 bytes. So that leads us to OKOMO, 8MO, 8 megabytes. Wait, is something wrong? 8? Yeah, wait. 8 megabytes. That's actually so much. Um, uh, do I really want to duplicate this into 8 instead of 4? I mean, the best is really to have something dynamic, really. Hmm. Mm-mm-mm-mm-mm. Mm. And yeah, this is basically just never mind. Well, minus is heat and everything. Like basically instead of a division we can have bytes minus chunk ID. Then we can do the same, so we remove divisions. So we optimize a little bit technically. Same there. Minus is hit. You could say. You can, I mean, you can make it an integer, but minus is hit, okay. Let's just do this in this case. And I mean, that should be fine because that should be how we compute things no matter the output texture, right? We should just like throw an error if it's like too much, probably. Well, yeah, then okay. But yeah, if I want to store like enemies and stuff, then it's going to be a problem, right? Maybe instead of chunk ID, it should be like entity ID. Mm. Mm-mm-mm. Actually, I can. Well, I mean, that's the object ID, right? In the end, that's just the object ID. Like object. Actually, there are two different things. There is the object ID, and there's the value used for the pickup. So this one might be a bit different. Like we can try having like different functions. Like for example, instead we can have the objects, so we can unpack is hit. Well, unpack what? Okay, unpack is hit. Then we have unpack object ID. And I'm just thinking a little bit, because we're not going to register like every triangle to like a hash map or a hash set, right? Definitely not. So we have the object. Then I guess depending on the object, we can have additional information. So like we unpack, well, if object is a chunk, then we unpack face ID, like quad ID, and then we have everything we want. But then, for example, if object is entity, then we do something else. And, you know, like we can deal damages, we can do stuff. And we can like store additional information, as I just said. Like I can store, for example, whether I'm hitting the arm or a leg or the head, right? That kind of stuff. So, for example, unpack body part, right? Something like that. So in this case, basically everything should be constant when we create the thing from the thing we're creating. So it's like there's a there's a dependency to the parent thing, you could say. Okay, we can try this, but I might want to put that in its own place, its own class, its own. I'm not sure. I mean, maybe pick up render pipeline. Maybe not the pickup render pipeline. Okay, for now let's just have it here. So let's say we have unpack is hit. So we're gonna take the integer bytes. Bytes, are we? 64 maybe? I mean, we don't have bigger than that, right? So I mean, 64 is like the maximum. But we can convert the uint 32 if we want. Okay, so then we do is hit equal this. And we do the minus. And we return whether it was hit or not. And we modify this. So now technically I can have. Let me comment this. I can have if this is hit. It's like bytes. Then I do I do something. Or maybe. Actually, yeah. So if this is. I'm losing so many values though. Am I? I am. Because of the division. It's just the first bit. So I guess the divided... Wait, actually it's just a minus. Wait, it's just a minus? Wait. Oh right, that's just a minus. That's not divided by 2. Wait, that's fine actually. That's probably fine. Is it modulo? Is it? No, it's not. Let's say it has to be equal. If bytes equal full, so I guess I want the end potentially, like bytes 64 potentially, and you have like this equal this and ff 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 ff. So that way it should... Well, wait. Actually, I can just check if this is entirely 0, right? That way I don't even have to check for a value like this. If this is entirely 0, then it's a problem. If it's not, then it's good. Right? Yeah. I have to divide by 2, right? I mean, I have to divide by 2, there's no other way. Wait. No, I don't. Wait. I'm a bit stuck, because that's not like a combination. This one is not a combination. I'm just checking if this is 0. And if this is not 0, then we do the thing. So it's like just a 1. But if it's not 0, then I minus 1. Wait, modulo 2. Yeah, minus 1 is not... Yeah, let's... Yeah, modulo 2... I feel like the modulo 2 is wrong for some reason. I'm not sure why. But I need a way to... Because I feel like I'm discarding way too many values if I do this. Because basically if I... Let me explain. Basically, let's say I have all of my values. That means I'm checking if like the first bit is like 1 or not. 1 or 0. But I can have like this. And I can have like this. And I can have like let's say the first bit represents whether it's hit or not. You know, I can have like this, I can have this, and you know, you see like correct values, but it's gonna say that it's not hitting anything because the first bit is false, which isn't how it should be, right? So that's why I'm a bit unsure about things. I mean, +1. In any case, I'm gonna do a +1, right? So Yeah, I mean, this is just -1. But then I'm not sure about this now. Because what if I... everything is just bad. Let's just check if this is 0. And if this is not 0, then there's a hit. So... then I just do a -1. Okay. Then we're gonna unpack the object ID, maybe. Unpacked object ID. So we have the bytes. Yeah, I just realized that it's actually not working like I wanted it to work. Because if I want to multiply, divide, and stuff... Actually, wait. It's just not gonna work. And it's like, well, -1, okay. I mean, it's basically... I could bit shift too. Let's go for the simple solution first, because we can make it, we can optimize it another time if needed. So yeah, I mean, I don't want to destroy cubes tonight, so yeah, let's do that. So we're gonna 1. It's like modulo, I guess. In this case, we can remove this hit. That's what I did before. Well, not 0, 2. Is it true? It should be true, yeah. Then we can unpack something else. Wait. I feel like I'm wrong. I feel like it's not supposed to work like that. Minus equal... I mean, yeah, it's supposed to be a division. Yeah, it is supposed to be a division. Not a minus. What am I doing? Okay, yeah, it is a division. That's why it was wrong. Okay, I mean, okay. Let's just continue like this, I guess. So now we have object ID. So we have potentially the amount of objects. NB chunks, or NB objects. Entities, you could say. NB, well, NB entities, NB objects, let's say. So by default, this is going to be, let's say, the amount of chunks that we could have, right? So out of this, wait, if we divide, wait. No, that's fine. That should be fine, right? So is hit if this modulo this, well, this is actually the 64, my bad. Object ID. I mean, technically I can keep this. Can I? Let's not. So then I remove or divide by this. And I return the object ID. And then I have, for example, unpack quad ID. And this is gonna be, what is the amount of quads? The visual, well, NBA visual quad indices. Times 6, maybe. Not really, but maybe. We do this. Then we divide by this. Quad ID. It's like the same function, right? So I could like make a, I could make something for that. Maybe like unpack ID in range. Like unpack integer in range. So we have this and we have like the maximum. Max value. Like actually size. Unpack index maybe. Index is fine. Well. Yeah, index is fine. It's good. So we have the size, so we can remove. We have the amount of objects, which we can do this. And this is just going to be return this bytes with, you know, the amount of objects. So like this. Okay. Then we have the same there. With this quad ID. And here we have, was it hit? Let's have it be 64. Oh, yeah. So we have this. If this is hit, then we check if, well, we check the ID. So object ID. Then we find the ID, the thing. So we find the chunk. So objects dot find basically object ID. Then we have the object technically. Not this kind of object. O, let's say. Object. It doesn't exist, that's normal. I'm just writing what's convenient right now. So then we have the object, we have object unpack, well, local object ID maybe. How can I call it? I mean, I guess object ID is fine. And technically, it should better be an array. Actually, it would be an array if it was a type, but it's not really a type. Yeah, I guess a virtual function is, it's fine. Is it? Maybe I can have like a, maybe the objects can be like sorted, and like we can have the chunks first, then the entities, then that kind of stuff, and that way we can have like the object type maybe. But in any case, it's gonna have to do something with the object, right? So it's gonna be objects on hit, let's say. We are gonna have the object ID, and basically it's gonna be like the flag relative to the object. And then inside we're gonna have unpack quad ID and unpack body part. I think that's it. I think that should be good. Should it? Yeah. It should be fine. I guess I just want to ensure that this is not going to to go above the limit. Yeah, I'm gonna check this when I pack. Okay. So maybe I want like an interface. Well, actually I have like variants. Well, Godot has variants. Maybe I can use variants. I'm not sure how optimized this is in C++. If this changes the table invariant OP, well, okay. Pools, small buckets. Okay. Oh no. There's no crash. Okay. Get type can convert. I'm not sure about that. I probably want an interface, but yeah, what about functions like Godot or variants? Better than interfaces in C++? I'm not sure about this. Usually no. Yeah. I'm not gonna use this. I can have a callback though. But the callback is going to be a bit more expensive. I'm thinking about how to make it compatible with JDScript, because that will be useful. But I'm not sure I really can. Maybe. hmm. I mean, I guess that's fine. Is it? Not sure. Yeah, what if I have like another module? Yeah, because this should be like in another module though, right? Because what if my entities are in another module and I don't have a reference right there? I mean, it should basically, well, if I implement the interface, then it should be good, I guess. I guess that would be good. Yeah, what about a collabel? It's a string name. And it's either an object or custom. So but how much? Okay, so you Hmm. Huh. I don't know. I really don't know. Right, it has to be, actually an array is fine. So if I have an array, wait, actually it's like free. It's free if it's an array. Yeah, it's actually free. Because it's an index. So I can have an array of collabels. Well, not like this, right? It's basically a vector of collabels. And I can like add a collabel, remove a collabel, and we can have like different things that are great. And that's where it's like not C++ dependent. We can have this be compatible with bindings, with like GDScript and stuff. And yeah, should be good. Like, I guess it's not about objects though. It's like about events. I mean, actually we display it to the screen, so I mean, I guess object is a fine name. So then we find, it's gonna return, okay, from, wait, from, there's a from. Let me just do this. Because I can, so I can get the object. The object is gonna be a callable. We are gonna callable this. Wait a second. Callable custom. What is that? Well, okay, it's virtual. For every type that inherits, this must always be the same for this type. So yeah, there's basically some type. Well, they're basically hiding type. I forgot how it was called, but it's like static polymorphism. No, it's not static because there's a virtual. It's type erasure. That's called type erasure. That's when you inherit from a class, from a templated class. But actually, it's not templated at all. I mean, good enough. Oh no, but yeah, no, this one is not templated, but you inherit from this class, and the children are templated. So you can have, for example, templates in your, well, templates in your class for like your function and stuff, and like, well, you can have lambdas basically inherit from this. That's capture specific variables with specific types, but that's like hidden, and you have like functions there that you can still call. So it's neat. So okay, we have this, a callable, and I should have like an argument. So call, and we have the argument. Okay, so callable, and I'm gonna call objects on hits maybe. On hit. Object on hit. Then we call this. And I don't remember what this is all. Arguments. Oh, this one looks bad. Call deferred. So P is like with the count. V is like with an array. Can I just call with this? Is it good? Callable. Callable what? Callable. How should I call it in C++ to work in GDScript? Just call. Find the method, create a callable, call the callable, wait, bind. What? Call later, so we call. So it's just a normal call. Okay. And it's actually callable. Yeah, it's to create it. It's like callable. See. Okay, that's fine. So I just code it. I'm going to code it with const. Wait. Do I need const? Oh, right, it's like a get actually. So is it gonna copy or I mean that's like a pointer and that's like an object. That's like a string name. So it should be fine if I just have it as a reference actually. Just a reference is good enough. Well, what? Oh, it's not returning a reference. Okay. I guess it's a get then. I guess it's this. But it's a vector. Why is it returning? No, this one is a reference. And it's a cow. It's a cow word. Can I still code it? If it's constant? I guess I can. Okay, I mean, we can do this. Yeah, I mean, I guess that makes sense. Get. That feels so weird. It should be like 01. It is. I really hate this. Maybe I'm just gonna have a local vector. I really hate the cows. That's like an additional interaction too. So I'm just gonna do this. The simple this. Then you have the callback we call. Const. Is it like always const? I guess it always is. Yeah, that's fine. So inside we have the object ID. And then we do the things. So instead of here, we are probably going to put this in the pickup render pipeline. Right. Pack pickup. Yeah, let's just remove this. That's actually starting to be big. Maybe I want a new object. A new class, I mean. Rendering. Render pipeline. It's actually about the pickup. Yeah, I guess I'm already splitting about features, right? Like chunks, like space. Actually, it's about types. Never mind. I mean, we can have... Let's have this. I'm not sure at all about all of this. That's fine. I'm just gonna create a class pickup. It's gonna be public. Oh, am I? Wait. Pickup output. Maybe I can do this instead. Input outputs. And that way unpack. So when I unpack, I'm gonna have the pickup output. That's like a byte, I suppose. That's like 0 by default, maybe. So I'm not going to have all of this anymore. I'm gonna have the pickup output, I guess. Like this. Because I kind of wanna modify it, but I don't really have to. Yeah, let's just have a copy, that's fine. Incompatible. Yeah, I know. Yeah, I mean, that's definitely wrong, but yeah. Maybe pickup. Let's just create this thing called pickup. Pickup singleton, maybe? Something. So we're going to have a list of callbacks there. Like this. That's going to be private, I guess. The byte is going to be private too. We're going to have on pickup. So it's a void. It has pickup output. And so this is like the output, I guess. I mean, I can convert, but this is fine. I can just convert anyways. So we have the output. I can do output dot unpack is hit. I can do this. That means I can make it so pick up. Well, well. Do I keep C functions? I mean, I don't have C++. Well, I don't have C functions in GDScript, right? So maybe I don't. I'm not really like this. Okay, maybe instead I'm gonna have this in my pickup class. Maybe it's better this way. So I have the pickup. Well, this is actually already here. I have the byte, let's say. Yeah, but now we have a uint64 that doesn't mean anything. Actually, it can just be an output. I can just do a using. But I don't need all of this. I don't need the reference. Output. Guess let's keep this. I mean, it's already like 1 AM. Shit. Incompatible. I mean, I can do this. Yeah. Unpack is hit. Yeah, let's just do things quickly. So his hit is gonna be there. Okay. Then we have, so this is fine. Oh yeah, this is bytes with a S. It's gonna be private. Right, I don't need this. I also have unpack index. Which returns surprise and index. And takes a size. So, like this. Okay, good. And then I have all of this. So I mean, this one is probably just fine. This way, I'm just gonna take the outputs. Output. And I'm gonna do outputs that unpack index with the amount. Oh, actually, I can just do this here. I can just have object ID, unpack index, this, with the amount of objects. So, I mean, I can even like remove this. So the amount of objects is actually just objects on hit, right? Well, objects on hit here. Right. So here we go. We have all of this. We get this. Then we call with not the object ID, but with the output. And for example, then we have I need a reference to the pickup though. But what? But what? But what? Should I go through the space? That shouldn't really matter, right? Whether I go through like the space or like the chunk directly. Maybe I can just optimize it a bit better though. Or not. Maybe not. Not at all. Yeah, let's go to cube chunk visual. Unpack index. I don't have it. I'm just gonna verify something. Air fail condition. I mean, it should like even be a throw or something, but I'm just gonna check if unpack. If basically the amount of bytes left. Oh, that's not gonna work. That's for the last one. I mean, maybe I can check with like the total size. Mm-mm-mm-mm. I do want a protection. I do want a protection. And that's gonna be a V at the end. Count V, I think. Because I want to return a value, I guess. Wait. Fl count V this. And my condition is going to be... Well, we're gonna have an amount. So that's gonna be like the max. Wait. Actually, never mind. I can... Yeah, that's fine. It doesn't have to be here. Yeah, this is good. I feel like this is gonna bite me, but... I don't know. So if it's hit... I still don't understand for the hit. Okay, I do understand. Okay, let me just ask quickly, because I'm not sure about those divisions. I want to pack values inside an integer. What is the most memory efficient way to store them? Can I use modulos and divisions to retrieve those values, let's say? I think I technically can, right? Yeah, you can. Bit field or mixed radix encoding, division and modulo. That's basically what I'm doing. Yep, that's what I'm doing. So this one is usually the best because you have like very fast operations. But we want to optimize memory, not speed. Fast, simple, no division, no. Yeah, for this one it's good. Mixed radix. So this, for example. So then we can modulo, then we divide. And yeah, it's basically what I'm doing, right? It's what I've been doing. So okay, that's good. Yeah, no wasted combinations. Yeah, that's what I thought. And slower, but you know, that's fine. I'm not doing that. I'm not doing it this much. 30 bits. Which wastes fewer representable states. A lot of states. Hey. Yeah, this is fine. Wait, what was that at the end? Wow. Did you do? It was a common pattern for voxel engines is this. Health. Wait. 32. 40. 40 bits. That's like 5 bytes, isn't it? Bit packing. Yeah, if I don't. Yeah, okay, anyways. Thanks. So yeah, this is working. This should work as expected. Then I call this. I have the pickup. A reference to the pickup singleton maybe somewhere. Okay. And let's have cube chunk visual. I can remove all of this actually. And this is just gonna be wait, the class is going to be, I can't forward if this is inside, so pickup output. Okay, this is good. So we're just gonna have on pickup, we have pickup output, pickup outputs, well, outputs. I don't even have to take a reference really. I don't have to take a reference. Because this is like already, let's take a reference anyways. This is the class. We're gonna go there. Oh wait, I have the tourist parameters. That kind of sucks, right? 2 seconds. Okay. So we have this. Boom. Yeah, the music is like really, we can't hear anything. Maybe that's fine. Yeah. So then we have the unpickup, right? That we bind to the callable at one point. Like we could do a register pickup maybe, something. Anyway, on pickup, output, right, I have to include it. Voxel rendering. Let's include this for now. We unpack the index. The index is going to be chunk visual. Well, quad index to cube index. This. Wait. Okay. So this dot size, I guess. Then we have basically the quad index, which should be this. And basically we abstract the texture. So we are not limited to the texture, we just, you know, divide, modulo, that kind of stuff, which should be enough to find the object back. So then when we have the quad, we should be able to do, well, to retrieve that, right? So we retrieve the quad. Well, we retrieve the cube index, which is nice. What is that actually? Size? What is size? Right, it's a cow. No! What even is this? Wait, oh, this one. Okay, I can't see it apparently. It's from cow. Oh, it's in 64. So I mean, I guess we can keep this. Oh, it's this. Quad index. It's an index, so let's do this. We then get the cube index. Quad index to cube index. Do I have something else? Triangle indices, vertex format. Divide triangle indices index by 6 to access. Right, that's why. 3 indices equals 1 triangle. Okay. Oh, but I also have the vertices though. So I should be able to get that, right? Technically. So I should be able to get the normal. But it's like floats, but that's fine, I guess. So it divides by 6. Okay. Yeah. I mean, I'm basically reusing the rendering data, so I don't really like this, but yeah. So I can have this. Well, is it a cube? Well, I mean, we have the cube, I guess. Then you have the quad index, so times 6. That's the triangle index. And from this, we can access. And then we have like one index. And we can use that to get the normal. And wait, is the normal? Oh no. I'm not sure about that. I mean, I guess I don't want to store normals. So I'm just gonna get the triangles. And I should be able to compute the normal from this. Because I have, for example, what do I have? Whoa. Oh, right, the color. Oh, that's so unoptimized. That's fine. And now create. Yeah, so normal. We build compute normal. So we have all of this. Compute triangle. Oh, right. Yeah, but it's not gonna be the correct one. Yeah, but I don't actually have the correct one right now. I just realized I just don't have it. So I mean, if I don't have it, Maybe I should like push it around there. I mean, it's like here though. Quad. Yeah, maybe just quad index to face index. It's cube. Yeah, maybe the face index. And this one is just gonna be the face. And the face is just this. So something like this. And this is actually in 32. Can I just have this? Without this? That sucks. I mean, I don't actually need this one. Wait, packs byte array. Oh, this one is nice. This one is fine. Okay, this one is fine. Because I don't need those many values. So I do this, and I'm just gonna clear at first, right? At the start. And now I should be able to access the... I don't need the triangle. I just want this. With the quad index. So we have the face. Which is a uint 8 face index. And now I should be able to do like whatever I want. Like what? I should be able to destroy, I should be able to, you know, do things, right? So maybe just call another callback or something. Like maybe for spaces and stuff. Maybe I need like a space context. I mean, I did say that before. That feels like a bit more like gameplay code though. So I'm not sure, but yeah. Hmm. Like on cube picked. I mean, I could even add this in the editor to do custom things in the editor and like selection and like editing and stuff. But yeah. So quad index, cube, face. I mean, I basically have everything. I mean, just the cube and the face should be enough. On cube picked. Yeah, picked is fine, it should be fine. And maybe I need like additional data though. I need another class. Core. Visual rendering maybe. I'm not sure. Interactive maybe. I mean, because it depends, right? Because, okay, I detected that I pick up the cube, but what does that mean? Does that mean I'm going to destroy it? Does that mean I'm going to put a new block next to it? What am I going to do with that info? And before I was actually in the visual, I had this, and I had some kind of callback at the end. But it was just a set, it was this. I was inheriting from this, and I could like do stuff, breakable and stuff. And it was kind of working well. But, right. My bad. I took too much time. Okay, let's do this and let's pray that we finish fast. The Raycast hit. I hit table. Actually, I think there are like different phases. I think I don't have to just stay there. I think I can gather arguments or something. Yeah, that's it. Yeah, that should be good. Raycast hit. Yeah, I'm just gonna... Intractable. Well, okay. Okay. I'm gonna have here a class pickable. Right. That's it. That's just it. Well, actually, do I want it to be in GDScript? I feel like this is gonna be like wasted memory if I do. I mean, it's only one time every click, right? So is it really that much? Store, connection. Struct, signal. Could do if I want some kind of class with well, that costs the minimum amount of memory, but that is accessible in GDScript. That supports inheritance. That costs the minimum amount of memory, but that is accessible in GDScript. What should I do? Or actually, is it? Maybe I can just have a callable, actually. Oh, maybe that's the way to go. But then I would have to describe different actions. And that means the booleans would be... I'm not sure about this. But yeah, I can have a callable. With like basically some kind of bit field, like bit set. Yeah, do we have bit sets in GDScript? Bits field? We don't. Bitmap. What is that? Two-dimensional array. Yeah, it doesn't. I mean, I can have an enum, because enums are available though. Yeah, but then there's a dependency problem. I can have a string name. Oh, I can have a string name. Right, that's a goal. Yeah, I can have a string name. Or like multiple? Wait, yeah, what if I have multiple? I mean, I guess it's like the amount of attributes. So, hmm. I mean, when I click, I should have the context though, because I only want to render the objects that might be worth it. Well, that are worth putting in the texture. So an array of, okay, I can try this, maybe. So basically, this is, I'm going to have struct pick up object. That's going to be an array, so vector, of properties. So fname is string name in Godot. Attributes. And for example, an attribute can be hit, or it can be interacted with, and that kind of stuff, right? That's like it's like matching an event, and we want to ensure that they match the event. So we have this. Actually, is it good? Because it seems like it's going to be a lot of arrays. Maybe I want to pack this. Like one. Maybe I want to pack this in pickup. Objects on hit. I could have a local vector too. And I would have objects to index. And then I pack the thing. That could be good enough. So I have a OR ID basically. That's a OR ID. That's right. That's what it's for, right? What is it doing actually when I create it? It's 0 by default. How do I allocate it? I mean, I guess I don't. I guess I just don't allocate it. Can I set it from uint4? I guess I can. Hash. Yeah. Okay. Okay, this is fine. So I can have. Let's say on pickup we have the string name, event name, and attributes is like callback. Well, supported. Well. Let me think. Let me think about this. I mean, I guess it's fine if it's in... No, it's not. I mean, there. Supports. That feels a bit weird. I'm not sure about this. It's already so late. Like, because yeah, I just wanted to pack everything basically. So like, supported basically, and then have something like objects on hit. Well, basically object index, so RID. And yeah, I guess I wanted to bind this to, wait, not the RID, but object to index. So like objects to index. Oh, wait. Actually, on pickup, I have the event name. What I want is a map that connects to the objects. Oh, wait, so that's not really what I want. I want to optimize this with from a string name to the object, so object ID. Yeah, okay, this is good. So event to supported objects. So to all IDs, I suppose. Well, it's kind of the same. We don't need this. And then we can get the objects on hit from the OR-ID, which is nice. Actually, 0 is supposed to be null, right? So I have to do like a -1. That's fine. Is valid, is null, yeah. Wait, what is that? Get local index. What? Okay. Okay. So yeah, should be good. Should be perfect. Let's create a new class. I'm doing so much, but I'm not creating a new class. I have to create one. This is pickup. For now. I don't know if I'm gonna rename this or not. Run the pipeline. For now, let's just add it there. Wait, that's a H. Wrong one. Remove. Header, modules, voxel, rendering. This one is H. Good. So now I'm gonna just remove everything and do pickup.h. Now this is gonna be pickup.h. Do I inherit from a node? I mean, I guess so. I can. Yeah, I can, because then I can add it as a singleton. So let's say yeah. Rendering device compositor, no. I'm gonna just keep this. Well, actually, yeah, I might. So yeah, maybe this is actually a node. Yeah, this is a node. This is like gonna be a subsystem. Maybe. Is it? I don't know. What about rendering system? Well, rendering device, for example. Rendering common, a device common. It's an object. And it has static functions. And it's like a singleton. Okay, so it's a singleton. Bind methods. Yeah, what about the get singleton? Is it like registered adds native task? Wait. No. That's OS. Wait, it's not. I'm not sure about that. But anyway, we have pcap on pcap. Okay, we have a bunch of stuff. Wait, what is... Yeah, I wanted to remove this. I might make it a GD class. Well, actually, let's make it now. And it's public. Okay. So here we go. Good. Now I can go on here. Remove this, technically. Because I don't want to make it even more of a mess than what it already is, right? Because it is a mess. So now that I'm doing something clean, I wanna make it clean, right? Pack input objects ID. No, I'm gonna remove this. Okay. So now I have this. Pickup is incompatible. Yeah, because we have the event name. And basically what we are going to do is we are going to find the objects there. Event to supported objects. That find. Const iterator. Maybe just a get. So we get the OID. Like this. I'm just gonna do a quick in private, well, uint 64 maybe. 64 is not needed, but yeah, it's definitely not needed actually. And it's gonna be well, OID to index, and then we have index to OID maybe. Index to OID. And we're just going to do a +1 and -1. I mean, yeah, this is fine. I'm gonna return OID dot get ID plus -1. And this is gonna be the opposite. I have the index and I do return index +1. Well, OID from this. And yeah, should be good. Should be good to go. Now I can do a very simple to supported objects. So what? Oh wait, that's actually just one. Wait a second, that's not good. I want a multimap. Go to C++ multimap. So I want an array. I mean, I guess std multimap or multimap. Wait, no, it does not provide multimap. I mean, technically, I guess I can have like a local vector or something. Wait, is a local vector copying, or is it... Ew. But yeah, I was basically thinking about something like that. Should I? Maybe I want to insert. Maybe I want it to be an ID instead. That could be nice. Well, a range. That can be an ID. I don't know what I'm doing. Let's just have this for now. So we have objects. Do I really want to store all IDs? No, I don't. I want to store IDs. Subject IDs. So we have the, well, project indices, let's say. Oh, reconnecting. Is it good? Okay, I'm back. I'm back. Is everything good? Seems to be. I don't know why it's restarting like that. It did that recently too, but I'm not sure what the reason is. And it's like a bit scaring because on Twitch it's saying that I have no viewers anymore because of the sudden restart. I guess you're going to appear like really soon. I guess it happens. So let's say we have this byte. Yeah, I don't really have the byte. So this, you mean 32 objects. And now I have all of this. I have the amount of objects. So this, I unpack. I have object index. And what I wanna do. What do I wanna do? Hey, everyone's back. I wanna get this from the index. Now I get the callable, and I call the callable with the output. Now basically there are different things that I wanna do. The first one is I want to call onPickup, and then I want to call the final callable. So I guess there are like 2 callables in total. So it's not on hit, it's like we're gonna have objects on decode, I guess, on unpack, well, objects unpack, if they have custom things inside. Oh, then you have objects on hit, well, objects on pick. And I guess it's gonna have some great data. Yeah, but actually, is it, well, so we unpack. And that data is sent to objects on pick. Wait, is it? Actually, it might just be like one. I'm not sure. I'm not sure about this. I mean, it does depend on the action. It depends if I want to have one place where I manage like everything, or if I have a lot of places where I manage different events. I think it will be for the best to have one place to manage everything for the pickup. Because otherwise it will be like... I'm not sure. Hmm. I'm actually not sure. I'm really unsure. I mean, I guess I can register... Yeah, this is not going to work well. So basically what I want is a function... So late already. Register callback for... Well, register callback. And it's going to have the name, the event name, and it's going to have the callable, right? So we should be able to get like the callables right away from this, and it shouldn't matter what any of this is. And when we yeah, but do I want to unpack everything? Maybe I actually want to unpack it gradually. Maybe I should do that from the side of the player. I don't know. Yeah, but that means I'm not sure. Yeah, but it's gonna depend like on what I'm gonna write though. Like what I'm gonna display on the pipeline is gonna depend on this. So this is kind of like important, right? Right? Yeah, definitely. Whether it's like the chunks. I mean, right now it's only supporting chunks actually. So it's like directly linked to the pickup render pipeline. It has to be an object that we can render. I mean, maybe I don't even need objects, really. Maybe I just want the callables. Yeah, but what about if I want to remove it? I guess it's fine. Mm. callable. Is it better to store callables or local vectors? Definitely. Well, definitely string name is better. This is tricky. I'm just gonna event name to event. Yeah, but yeah, we also need the objects we want to render, right? So we can't do this. Two object indices. What if I just have a local vector? No, actually. Yeah, let's stay data oriented. We're gonna have a list of objects that are going to draw. Objects on draw. Can I actually do that? I mean, it's gonna be a bit slow though, putting all of those callbacks, isn't it? It is. Free OID, nah. Yeah, there. I can basically draw, but at what cost? So for one chunk. I mean, I can have it just be chunk for now. Oh. Why is it taking me so much time to do this? It's so simple, but I want to abstract it somehow to make it like the best. But I think it's like I'm just losing time, and I have to focus my time on things a bit better, because I can always rework it a bit better later on. So let's say I want to register a callback. So for example, when I destroy a cube, like when I hit, then I want something to be called. And the argument is gonna be, right, it's basically gonna be the type. So for example, it can be like a chunk. I guess it's gonna be a variant. Is it? Well, that sucks. An object. Yeah, I mean, I guess it has to be rendered anyways, right? So I guess it should be an object, at least. A node, maybe. Okay. And from this we can test, and we can destroy, or we can interact, we can do stuff. Okay, that should be good. Maybe. And maybe we can add like an exception if we have like some kind of screens, or I don't know. So just callbacks. I guess it's fine. Yeah, what about the unpacking though? Events to, well, event name to events. So we have this, we have the different events. We can just create it. It should be a reference, because otherwise it's a copy probably for this one. Then, I mean, we have to check if like there's a hit first, right? So if there is one, then we get this. Then we do this, and the objects we unpack. This is actually a bit tricky, but I mean, I guess it's fine because no, actually that's fine. Oh no, we also need the data, right? Oh right, that's right. Yeah, but I'm binding with like the event name. So if I have like a callable, I should be able to call it with the right arguments. Okay. So let's say I unpack. Wait, can I actually do that? I can't. Wait. It can't be that dynamic because I have to store things in... Oh no. I did all of this for nothing. I mean, I could update the buffers regularly, but would be a bit bad, wouldn't it? Like, if I want to update all the buffers whenever I create like one more entity, then that would just suck, right? Because yeah, it's dynamic, but at what cost? At what cost? It has to be fixed. Fixed. Hmm. So like this dot size is kind of not working. Is it actually? Yeah, it's definitely not. Um, I mean the chunk index should be fine. Actually, the object index should be fine because we can send it as a uniform. Actually, it might be fine if we send it, as long as we send it as a uniform. All right. Oh wait, that would be crazy. Yeah, because that's only... Oh, right, wait, that's good. Wait, that's good, actually. No, I can do it, I can do it. I can do it. Okay. So, event name to events. And so I unpack. So then I have the events. Events. And then I guess I just call this. Event. Like this. And output is the pickup output. Yeah, okay, this is fine. Okay, this should be good. That should be good. And other than that, so okay, I have this. I have register callback. So this one is like pretty simple. We're basically just going to add this there. I mean, it's like a hash map, but Robinhood hashing. Oh. Swap out entries that have a smaller probing distance. Slight performance overhead on lookup, which can be mostly compensated using a page allocator if required. Ah! I'm not sure about that. Push. Is that just going to work? Or is it going to say I can't modify? No, it seems to be fine. I guess local vector is not a cow either, so that's good. That's a good thing. And then I guess I can unregister it. Potentially. And I should be able to erase. Maybe. Yeah. Yeah, maybe. So then I have the event, I call the event. So I guess what I want is like a singleton, really. So I might do a get singleton. Like static this pickup. Yeah. 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 Get singleton. There's also the make current. Oh, random. Okay, never mind. And how is it implemented? Okay, just return. Where is singleton? Like there, basically. And I return it. Wait, but when am I instantiating it? Equal now. It's basically not really a rendering cell in the constructor. Okay. I mean, okay. And when is it instantiated? I don't really want a singleton though. Go to autoload C++. Go to module autoload C++. pure engine singleton. Custom modules. Register coursing. Well, oh. Customizing module types. Wait, this is good. Modules can interact with other built-in engine classes during runtime and even affect the way core types are initialized. So far, we've been using register summator types as a way to bring in modules and module classes to be available within the engine. A crude order of the engine setup can be summarized as a list of the following thing: core singletons, server singletons. I guess in my case, it's like a server. Our summator class is initialized during register module types call. Oh, never mind. That's like the example. Imagine that we need to satisfy some common module runtime dependency like singletons, or allow us to override existing modules. It can be assigned by the engine itself. In case we want to ensure that our module classes are registered before any other built-in type. Pre-register summator types method, which will be called before anything else during this. We now need to add this method to register types. So pre-register summator. Wait, the pre-register. Okay. And like other register methods, we have to explicitly define this. Oh, to let the build system know. Write custom document. Oh, this is different. So code before any. Let me check this. Pre-register. So like there, for example. Initialize. Wait, what? Never mind, I don't know. Initialize Gislong. What about you? That sucks. Pure engine singleton. So we have this, and then we implement CPP, bind methods, print hello, and register it in register types. Initialize register class and singleton register singleton. Okay, so we have this. Oh wait, it's like the get engine get singleton. Oh, it's like get the engine. Okay, that's fine. Then we assign it. Wait, it's not even. Oh, it's there. Never mind. Okay. Oh, so I can just do engine get singleton actually. I can just do something like that. So in my pickup render pipeline. Oh, actually, do I want this? Maybe I want this in the space, and I want it. Well, and I want to assign it like one time. Well, in the space visual, probably. Is it the space visual? Pickup cycle. Icon. That's probably in the space. I mean, maybe. Oh, does this even have anything to do with the visual, actually? I mean, so I'm gonna... Let's say I bind this. I have the event name, I have the output. Object IDs. Yeah, but then we have the problem with the IDs, right? Yeah, that... Ah! That's not really what I want, is it? Is it? Actually, it's... So we just write the callable. The index of the callable. And I guess that's it. I'm so lost right now. Because I want to do things in... I feel like my modules are not split enough. They're not clean enough. Let's just say... Let's go in... maybe bind... I mean, it has to go there at one point anyways. So... pick up. Wait, that's not the place. Current document. Pick up. Nothing. Chunk space. Oh, that's a space, that's fine. Where was it? Cube, chunk, visual. Okay, so we have all of this, we have the faces, and we have on pickup. Like, I guess we have the decode. Maybe register pickup. Register pickup. Let's have this. This is gonna get the pickup as an input. Or like, I guess pickup is fine. It doesn't seem to be. Right. Wrong one. Now it's... and the pipeline? Pickup? So we have this. Register though. Like this. I guess it's a nudge after all. Like this. This is a class. Then we get singleton. Get singleton. What about singleton objects? P name. And this is just engines. Oh, engine store. Right. So get singleton object. We have the string name that's gonna be well, pickup, let's say. So we can have actually wait, yeah, I mean it doesn't have to be here. Wait, actually that's a bit complicated. This could be like another module in itself almost. Okay, for now let's just have pickup. Let's go in register callback. I guess we don't want a singleton there for now. Like an engine class, well. Register. We are going to have. What are we going to have? What are we even going to have? On heat. I mean, on pickup, this is just going to be parse, right? So the callable is going to be call. What was it again? MC. No. Godot create callable. From a function. Just equal, I guess. Oh, actually, no, C++, I forgot. Right, that's Minecraft. No! Callable MP. Callable MP. And we have the... What do we have? Wait, what was that again? So this and the thing. This and on pickup, for example. Okay. So on hits, well, on left click, on click, on right click, on anything, right? It's just a click, like it's an input. Like I guess it's yeah. Well, I mean it's an input, I guess. Anyway. I mean, I was thinking maybe it's just going to do something different depending on like the, you know, the callback and stuff. Well, actually, no. Okay, you know what? That's fine. So we register this on hit. Well, on place cube. Well, on left click, let's say. On right click. We are gonna have So instead of this, I'm gonna have destroy, well, on destroy block, for example. Well, yeah. Like, for example, on destroy block. So I'm going to decode, like unpack, unpack pickup outputs. So we're gonna have this, we're gonna have this, and I guess it's kind of very specific though. So that's why I was thinking about making it a different module. So technically we unpack there. So we have the cube index. Wow. Cube index. There should be a 32 probably. And then we have face index. I think 32 is good enough. Yeah, it's actually a 32, so I can't go higher than that. Okay, here we go. So we can unpack very easily like this. And when we destroy, I want to unpack this with cube index and face index. Quad index to cube index. Wait a second. Okay. Has no member on this block. Yeah, I know. Wait, what? Yeah? Yeah, that's why we're gonna create it. And it's not constant. What? Something like this. On this block. And that's a 32. And now we want to actually destroy the block. I mean, I guess it can be a lambda, technically. It could be a lambda. And the destroy block is going to be... I mean, we already have it, don't we? It's like... Well, okay. Yeah, let's maybe have it. Clearly. Destroy block. We have the index. I mean, I guess that's it. It's just gonna be a copy and paste. So this doesn't exist. So let's create it. From the cube index. I can just set this. Can I? I can't. Wait, cube chunk. Right. You're right, I have to convert. So I get this one. I get the cube chunk and I can set a block basically. Well, this is basically going to be a destroy. So there's going to be some logic behind it. Destroy block, I guess. Yeah. Let me think. Yeah. With like the, well, destroy cube. I guess cube is better. It's more suited for like the class and stuff. Destroy cube. We destroy the cube, so it doesn't have this right now, but it's going to have it. And then we should mark it to be rebuilt, but we shouldn't rebuild it now, basically. And yeah, I can just remove this. And destroy cube. Let's go in. Well, actually, cube chunk. Let's go there. Public set block. I'm gonna have the destroy. Destroy cube. Maybe I want to, instead of triggering a callback right away, I think I might want to wait a little. I'm not sure though. But it's gonna become frame dependent if I do that. Or maybe not. Maybe not if maybe I have to wait. Maybe it's about order, I don't know. Anyway, we have this. We're gonna go there. We're gonna have the destroy. Wow. Destroy cube. Cube chunk. Wait, that should be good. Wait, oh, there. My bad. Okay. Then I can just set it, I guess. Technically. Set it to what? To 0 for now. I'm gonna destroy cube with the cube index. And I can also place a new one though. Yeah. Unplace cube. So we have the output. Yeah, it's about the controller, so I don't really want this here. But this is fine. I'm gonna place the cube. Maybe this one should be like in a C++ module. I don't have it declared. So let me just forward declare it. So now there shouldn't be any issue. So once again we unpack, but this time we want to place a cube. And what should I do with this? What should I do with this? I mean, because it has to do with the face index too. I mean, it does it? It doesn't. It doesn't. I need the direction. So let's go up. Maybe not. Let's go there. Neighbor. I mean, yeah, you have the neighbor somewhere. Neighbor block. Oh, normal. Yeah, get face normal. Perfect. And I have the neighbor. So let's do this. Can I get the normal, well, the neighbor offset, actually? I should be able to. Local cube coordinates. I mean, I could convert it like to an index right away. Actually, can I? Well, I mean, in the case of a cube, yeah, I can. I don't know about the rest. Pose index to, yeah, to cube index. Yeah, I mean, I have the cube index. I have the face index. Wait, I have the cube index. Right. Okay. So then the connections, yeah, I should be able to get the connections without passing by what? I don't know. I mean, pause is local cube cards. Yeah, this is already this. Right. Right. Let me go there. Type. Oh, right, wait. Yeah, that's not good at all. Well, kind of. Well, I guess it's a different referential once again. Oh, shit. So, neighbor index. Yeah, but I don't have any. Actually, that's normal. Actually, that might. Yeah, what if it's not inside the chunk? It's just not going to work. So I should just call the space station. Can I get from this to the worlds? Maybe that's a bad idea. I should definitely call the function from the space though. Space. Chunk space visual. I mean, I guess. Then I get the space, the actual space. And then I do a place cube. Right? And I mean, I guess this should be the same. To do call from space. Call from space. Not really, but yeah. So we have the place cube. I'm not I mean, I guess I prefer sending things directly, like from the chunk. Select chunk. We also have the local cube index. So maybe it's like the cube position actually. I mean, it's not a position though. Let's do cast 2 cube chunk space. That way I can be a bit more specific about things. Cube space. Now I can place a cube, but I can place it from a chunk. I mean, actually, let's just code it like this, like with so you have chunk Norris. No. Yeah, we have the cube index and we have the face index. Wait, cube index is actually. Wait a second. Cube index, what is this? Oh, wait, this one should be fine, right? Quad to cube. Yeah. I think this one is fine. Cube index equal. Wait, what's that? That's a raycast. So we push the block. Oh no. But it's only if it's like generating it though, right? Block index. Oh no, that's actually fine. Yeah, no, that's fine. Never mind, that's fine. So yeah, that's the right block index. Okay, yeah, okay, that's comforting to hear. So then we have the chunk, I guess. We want to place a cube, and we have the face index. That's fine. Yeah, that's fine, that's fine. And there, we're going to have the public. We don't have the break cube here, actually. But we do have, well, that's normal. We do have chunk, well, cube chunk. Is it? Yeah. Class cube chunk, in this case. We have the cube index. So this is uint32. Yeah, I mean, I'm gonna add it to my referentials, really. Voxel helpers, no. Wait, it's not even here. Core. Oh, that's a header file. Yeah, never mind. No, that's not. There. So let's say we're gonna have. Can I inherit from an integer? I can't, right? So I guess I'm gonna have to store it. Oh, that sucks. Local cube index, maybe? So we have the coordinates, but we also have the index. And I mean, this would be like more optimized, really. Just to store it as... Well, actually, that's less data, though. Never mind. So, local cube index. Yeah, local cube cores. This one is like not optimized at all. This one should be an integer, actually. Maybe. Maybe not. Yeah, well, I guess it would become a bit complicated. Yeah, let's just have a using. Should we? No. index. Then we have the face. Like this. So we place. And when we place, I basically want to get the chunk. So I guess it's like chunk get nape. No, I can't do that. But I mean, I can still try. Like, I mean, this is basically going to become the neighbor. Neighbor local cube index. And let's have a function. Yeah, let's make it because we're gonna have to use it anyways. Cube chunk. Set local block. Coordinates. What about the index? Get block index. And we should have get block chords, basically. Get block chords from this. From the index. Should it? Yeah, I guess it is. So then, okay. So this is basically going to be the same, but a bit different. So first we want to remove x. Maybe, wait, do we want to remove x? So it's like a modulo, basically, right? Okay, yeah, that's it. So it's like this modulo nbblocks.x. Yeah, okay, that's fine. So now we have, well, chords, return, chords.x equal this. Then you have index, and we divide by this. And yeah, we just basically continue iterating like this. But then chord y equal index modulo this. And that gives us position y. Chord y. And then we have the division and we get z. Z. Y. We divide by y. Then you have chord z equal, well, just index, right? Just index. It should be good. And wait, that's if we consider that this is correct, though. If we consider that this is correct. Oh, no, never mind. No, this is fine. Yeah, this is correct. This is correct. This one is correct. So now I have chunk chords, get block chords from this. And this is basically the neighbor local position. So neighbor local pos. I don't know how efficient it is, really. Well, I need the coordinates anyways at one point. Yeah, okay, I need it anyways. So then I'm gonna do this. I could do a plus equal. I'm not sure if it's gonna work, but I can try. Cube chunk. Not there. Cube chunk visual. Neighbor. Cube chunk get face normal. So like this. Vector free I. That should be good, right? Looks good to me. And then I guess we want to verify if this is inside the chunk. Then we just remove it. Well, inside. Well, local is in chunk. If this is inside, then everything is good. Most normals. Yeah. And if it is not, well, if it is, we destroy. If it is not, we want to find the right chunk. So if it is not, we do chunk equal. Well, we have all the chunks there. Chunk cores to check. Oh, right, I guess we want to get the chunk that is next to it. So I don't even have to convert into worlds locations. Oh, that's actually neat. I'm not sure about that, but that's kind of neat. Chunk cost to chunk index. I mean, we could search through the chunk cards. I mean, if it's not inside... Oh, yeah, that means it's kind of trivial, actually. Yeah. Because I should have chunk cards. And I can just do... Oh, that's so crazy. I can just get the normal. Like, yeah, because this is like in the same direction as the normal, right? Wait. Face normal. This is crazy. Optimization, baby. So I do this plus this, and this is the new chunk coordinates. New chunk cards, basically. From vector free I to this. Wait, what? Oh. Right. Because it returns... I mean... Plus. Face normal. I mean, in this case, it's fine, but yeah. I can understand it. So then we have the chunk coordinates, then we can just get it. New chunk cards. Oh, we can't get the pointer because it might not be loaded yet. It might not be loaded yet. And if it's not, well, we can try to, we can request it. But yeah, No. Not again. So wait. Oh, this is a pointer of a pointer though. No, it's the chunk index actually. Oh, that's the chunk index. Right. Right. That makes sense. I actually don't know if like my array chunks is really needed or not. But anyway, we have the new chunk index. And if it's not loaded, well, if it's not this, to do load / generate. Yeah, maybe make a load chunk or something. Apply, generate all, try load chunk. Yeah, but I need like the index and stuff. Like this. Getting so late. You chunk cards. Like this. Again? What is it with 2H? Oh no, never mind. I bent it already. Never mind. So we have the chunk coordinates there. And it should be alright. Should be alright. Maybe I want to push events or something. Anyway, let's say this is fine. We try to load the chunk, and we're just going to have a little problem here with air break, maybe. If there is no sensible error message, well, fail, let's say, like error unimplemented. Is it? No, it's not there. Well, fail, unimplemented. So okay, we have this, and if this is good, then we just have chunk equal. So there's just a few more computations, I guess. Not that much. Well, it shouldn't be that much, but yeah. And then you just have chunks. New chunk index. What? Cube chunk. Right. Yeah, come on. Just two. Cube chunk. This is fine. With this. Okay, we have this, we have everything. And this should be valid, always. So let me just check if this is none. Or not. I mean, yeah, it does. Anyways, yeah. And after that, I wanna... Well, I just wanna place the block, right? So like... well, set block, can I do that? Set local block. Okay. And I just realized, but I can actually optimize things a bit. because I have the local position, right? So if it's like the local position, I should be able to modulo this. Because it's just a +1, right? So it's like a modulo in that direction. Like, I guess it's a 0. Well, yeah. So this, well. Well, yeah, I guess it's this XYZ. So can I just do modulo equal chunk NB blocks? Yeah, I can do that. So now we modulo, we ensure that this is inside but on the other way. Maybe. Or maybe not actually. I mean, I guess I want a plus equal. Let's have this equal this plus this modulo this to ensure that this is positive, right? Well, actually, if it's -1, oh, it's not gonna be good. It's not gonna be good. Yeah, what is that? That's not good. That's dumb. I mean, at this rate, I can have like the global coordinates. That's local. Can I do a global to local? Wait, no, okay, my internet broke, right? It hasn't been like 1 hour. It's been 4 hours just for that. Okay. Set load. Oh, set local. I can set the local cube. The local block. I mean, I guess it's better than going through world positions. I prefer doing this. I'm just gonna do Newton coordinates. This one is fine. Maybe I was wondering, like, can I actually have a world without world positions and just have neighbor chunks? That would be amazing. And like you know, some kind of list, some kind of graph, because that way it could be like compatible with non-Euclidean geometry. And I'm wondering what kind of algorithms you can do, like for generation with this, basically. Because then things would be local. And maybe it wouldn't be that bad. Maybe it wouldn't be that bad having some hierarchical thing going on. Technically, chunk space. Maybe if I inherit from space, batch transform. Chunks. Yeah, chunk space. What if I inherit from space and have something a bit recursive? That could be fine. That could be good. Good. And local block. I mean, I already have the normal, right? So in that case, that means I already know the direction. Right? So in that case, can I get like the coordinates? Yeah, I have like the operator. So I should be able to do something with this. So like for int, well, u maybe, axis equals 0, axis is less than 3, plus. I'm gonna get this axis. If this is higher than 0, then, well, let's do that afterwards actually. Boom. New chunk index. Yeah. So we have the new one. And if this is higher than 0, then we have the local coordinates. Well, I mean, it's gonna be a bit different. Well, yeah, let's just set local pos. So local pos is going to become axis equals 0. And if it is less, so I mean, I guess it's a switch actually, with -1, 0, and 1. So if this is -1, we do this. If this is 1, we do this. I don't know if it's gonna help the compiler, but yeah. So -1, well, actually, +1 becomes 0, and -1 becomes NB blocks -1. And you know, we have the case with 0, we just break, and defaults. I mean, that's an invalid normal. Invalid normal. That's not a condition. Here we go. Yeah, I guess it's like axis. Okay, here we go. And now it should be like kind of really fast. And we should have the local block, the local position. I mean, it doesn't even really matter that it's this fast, that it's this optimized, but yeah. And local cube coordinates. Local cube coordinates type. Wait, type? Oh, because it's from the GD. Wait, what? Why that? Set local block. What is this local block? Oh, there. Oh, it's private. Oh, right, I need the type. I mean, this is fine. This is just gonna be the air. Well, actually, it's not. It's gonna be one A, because we are placing it right. I mean, I really well. That's a cube. That's a block of stone, maybe. So okay, that should be good. What about the break block? I mean, the break block is already done, right? That was kind of straightforward. I have to sleep, like really. I do have to go. But at the same time, I really want to finish this. I'm just gonna cast, well. I'm gonna cast there. Chunk. To do callback in space. Okay. That way, basically, we can also handle the networking data through the space. That's why I'm putting it there. So we can destroy, set, rebuild. Yeah, what about the place though? We should be able to rebuild. So we set the local block, and then we rebuild. Please. Oh, there's no visual. Oh wait, I kind of have access to it. Get visual. Yeah, I guess it's like a bit difficult, but to do remove dependency and replace. Actually, replace by callback. Maybe. Let me think. Set local block. I mean, there should be like a dirty flag, right? Like, well, a signal. Godot C++ module signal. Callable, that's not really what I want. Trigger event. I mean, I can't do this. Add signal. And emit signal. Okay. Let's do that. So there, cube chunk. Actually, is it a cube chunk or just a chunk? I think it's just a chunk. Let's go in the parent. Find methods. Okay, there. So it's gonna be add signal method info. Custom events. So the event is gonna be on, well, dirty, on change, on block set. I really have to decide when to update things. Like I need a specific order to update all the things. I think I feel like. I definitely do. I mean, do I have chunk visual process update? No. Unchange, maybe? I mean, unchange can be fine. Then we have property info. So it's basically the arguments, right? So variant and the type, like string and the name. So I mean, it doesn't have anything, right? Maybe it has a reason for the change, but there shouldn't really be something big. Like, I mean, this should be enough. So then, kubechunk, set local block. We have an emit. I mean, maybe I just want to push into a stack of events. That way I can do undo, redo too. Maybe, I mean, that's not my goal, but well. Just set a boolean, verify afterwards. I don't know. Hmm. Let's just emit the signal for now. And the signal is going to be, I mean, we need the string name. So, wait. Chunk on change. Let's have string name on chunk change. Changed equal on chunk changed. And it's not good. Member should be const. Wait, what? Should it? Member of type const string name cannot have an in-class initializer. Really? No! Okay. Oop. Like there. I guess. Wait, it's not right. Because of this. I mean, I can have it inline though. Okay, yeah, I have it inline. That's fine. So here we go. And then here we go. Then you have this. 3 AM. No! Emit signal. We emit this signal. And it should be nice. Nice and good. And in kubechunk visual, we don't want to update every time, but you know, kind of. Uncube picked. Wait, what? Unpack. I guess I just want to unpack, right? Wait, what? Oh. Okay, I guess this one is on destroy cube. And this one is on base cube. Here we go. So this one should be not here anymore. On pcap. Let's remove it. And then we have at the initialization, which should be somewhere. Do I even have it? Rebuild mesh. I mean, I have something like this at the beginning, but wait, what was that? On chunk change. When am I setting this thing again? Chunk. Set chunk. I should have it somewhere. Oh, actually in the parent. Oh, right. So, I mean, I guess I should rebuild there. Well, I can, technically. Set chunk. Yeah. Yeah, and I actually set the visual. And there I can do in chunk on chunk changed. Or like how do I listen? Connecting to a signal. Callback method. Wait. That's not. Add signal. Bind the signal. Bind the method. What? Disconnecting. Oh, right, I want to connect, right? That's like connect with the name. Like this. Like chunk, I guess. And the callable is refresh visuals or rebuild mesh. Kind of. I mean, I guess it's a callable. And callable, how do you make it again? It's just callable? No. Make callable go to... Actually, okay, yeah. Yeah, okay, that's just it. Callable. This. Is it? No, it's not. Method name. Ooh. Wait, but I made it in... I did something in pickup. I have all of this. Oh, but I'm not creating it, am I? No, but I'm doing that in chunk visual, right? Actually. Wait, I'm really not doing it anywhere. Well, not there. Cube chunk visual. Register pickup. Callable. MP. Here we go. Yeah, and what is it even doing? Pings. Custom callable function pointer. Okay, this is nice. So let's go with this. Let's go with rebuild the mesh. And this should be fine. It doesn't take any argument anyways. So we connect and it should be good. Okay. Set chunk. Well, to do cache. Or should we? Maybe in rebuild mesh we just have a boolean hasn't changed then. Well, I don't know. I don't know. Well, to do cache until end of the frame, you could say. Yeah. I mean, I really want to do my list, basically. Like, have some kind of manager that handles events in the right order. That's kind of what I want, really. But yeah. And other than that, I don't really know. There's so many optimization to do, that's the problem. But at one point we have to actually make the game, right? So I guess we can rebuild it. And I mean, basically right now it should mostly be good. So I'm just gonna, well, I'm just gonna close. I'm gonna start it again. And I think I'm missing one thing, but I'm not sure what it is. Right now I have pickup. Yeah, wait, I haven't even registered my class pickup. Okay. Okay. That's fine. Let's pick up. Register callback does not take one argument. Oh, right. Wait. What? Does it? Register callback does not take one argument. Yeah, it takes two of them. Connect function does not take one argument. What? Okay, that's the wrong errors. Function must return a value. Yeah, I guess it's no. Well, I guess it's v, and we return no. Well, return value and message. So NPTR and this. And this is always gonna be this. Then see declaration. Pick up output to variant. No! Wait, does it want to convert? +1, make sure 0 size arrays are also supported. No! And safe use of type boolean in operation. No! I mean, I guess we can have hit equal this, maybe. Hit is different from 0. And you have hit divided equal. Yeah, that's right, because it's a division. That makes sense. I mean, minus equal would have been fine then. Would it? Wait, what? Wait, that's not how you do it, is it? Modulo size divided by size. And the size is 2. Oh no. Oh no. It's like this. Maybe. Yeah, I think that's it. I guess I can just return it is not 0. Okay, here we go. So it's really similar. It's kind of really the same, actually. I cannot convert. Yeah, I'm not sure about that. Pick up output to variant. Why is that? Why can't I convert it? And why do I have to convert it? Illegal. Oh no. It's illegal. What? Shift count negative or too big and define behavior? No. $64. I mean, should be fine. Count negative or too big? Too mean. Must return. Okay, let's try compiling again. But yeah, we still have a few problems with the callbacks specifically. I wasn't planning this. I mean, I can make, actually, I can, wait, arguments. Yeah, because if it's like in GDScript, that means you have to, well, it has to be a variant. It has to be serializable. Output. So get the non-variant as input of callable. Actually, I guess I can write cannot convert to variant callable. C++. You pass a row C++ lambda or a standalone C++ function pointer. Directly, we're going to expect a callable or a variant. To bound specifically to a standard Godot object or ref counted derivative. Standard C++ functions like this metadata layer. I mean, I guess it can be an object then. Like a ref counted, I guess. Maybe a ref counted is better. Let me just check this. So itineraries from object. Yeah, why do... I just don't understand why it has so many variables. I hate it. Like, why do they all have this? I don't need all of these. Tools enabled. At least this is removed when, while in release, right? Mutex. And a bunch of stuff. Okay. See reference to function templates. No, illegal. Illegal operation on bound member function expression. What do you mean? It's not. Oh, does it have to be... Oh, right. Does it have to be this? And I'm just gonna... unpick up. Yeah, I mean, I still have to do a lot, actually. I really want to finish this, but I'll probably be going for tonight. Sadly. Yeah, this is a ref counted now. So I'm gonna have a pointer. Ooh. Here we go. And let's have type class, but has this. That's fine. I mean, it's actually a ref star. Well, it's a ref. Output. Yeah, can I have this and still modify what's inside? I guess I can, because it's not a const ref, a const pickup output inside, right? Declaration incompatible. That's what you think, right? Maybe not. Oh, right. The reference. Okay, should be good. So you have all of this, but we haven't even registered the pickup output, right? I mean, it's a reference now. So that means I'm gonna have to do the thing to the class. Here we go. Yeah, it's really not needed. But yeah. And in Vox, well, in the render pipeline. Wait, that's the only one I have here. Oh, pickup is there. What is it doing here? Not even in rendering. Oh no, it is in rendering. Never mind. Let's include it. Well, actually not here. Let's have the pickup. It's null. It's null, okay. Then we do things, and basically at the end, we have the readback. We have this, we have the object ID. And what I want to do is if there is a pickup, then we pick up something. We're gonna include modules, voxel, dish, well, rendering, pickup. Oh, it's inside this time? Yeah, that's a bit weird, but okay. Pickup? On pickup? Event name. Yeah, what is it even supposed to be? String name, event name. I mean, it's going to depend, really. By default, it's gonna be nothing, I guess. And then we have the ref pickup output. I mean, I can update it. I can have like a single reference here and just cache it. That's like a possibility. That's like an option that I don't mind having. Is that protected? Okay. Yep, output. So I guess there, if this is null, I'm just gonna create it. So that's like a mem construct copy. Wait, construct new, mem new. Okay, I guess I can just instantiate actually. Like this. Hehe. Now I can put it there. And I mean, I just have to update a few things. Well, I mean, actually, I can't do anything. Okay, I have the pickup. Yeah, there's like nothing there. Reset. Yeah. Reset to in. Or maybe it's supposed to be a float actually. Well, let's not have a float. Let's just have this. Bytes equal in. Well, it's a code, really. It's a code. Like it's a object ID, or I don't know, right? It's something, definitely. So then I have the reset to, we have the object ID, right? Yeah. Yeah. This is good. So now we pick up, we do the things. We also need to add a uniform about the buffers. And the object ID? Yeah, well, that's basically the same. So in chunk visual, well, sorry about this. I mean, we do have to construct the ID too. For now, we haven't constructed it yet, actually. So this is kind of a problem. This is actually kind of a problem. Okay, I don't have the time. I'm gonna finish for tonight. I'm just gonna try compiling, and if it's a success, then that's a success. Okay, building. Interesting. Prelude. Okay, no, this is actually good. This is actually not wrong. See declaration. Overloaded. Illegal. Oh yeah, I do have to put this, right? Yep. Yep. Ref no appropriate constructor available. What do you mean? No? I guess. Let's try again. Signed, unsigned, shift. Can I convert argument 1 with R equal floats? What? Float? I mean, I think it's because it's wait, actually, register callback on pickup. I call outputs, which is a bit different now. So that makes sense. But output is right. Yeah, that's fine. I have this. On destroy. Wait. Place. Destroy. That should be good. Now we replace like this, even. Okay. And yeah, now it's just the arrow went back. But that's basically the only difference, I think. Now it should be alright. And yeah, we want to add a uniform for each object. And yeah. Oh, this one can be dynamic though. Anyway, let's pick up output undeclared. Okay. Wait, really? Oh, right, yeah. Yeah, that's right. This from ref. Cannot convert ref to const ref. What? Wait, is it const? No, it's not const there. Okay, I think I have the pickup there. That's not really what I want, but must return a value. Wait, what? Why? Why? On this tray cube, same for this one. Why? To do... Hmm. Let me add it to my notes. So, to do... We have... So this is done, this is great. I don't have all of this yet. I'm focusing on, well, removing implement raycast via GPU, okay? Let's do make raycasts do interactions with the world. Well, slash pickup. Interact with the world. Yeah, I'm not sure about large world coordinates because it seems like such a problem, especially with like non-Euclidean coordinates. I'm not sure about that. To make it more flexible. Never convert world position to Taurus. I mean, the core is fine. The core is fine. But then it's like the visuals, and then you have the collisions on top of that. It's collisions that are just horrible. Collisions are going to be pretty bad. Mm. Mm-mm-mm. Actually, it shouldn't be that bad. I should just change the shader and the position, the world position, basically. But that's... I'm a bit afraid about how difficult it's gonna become to debug this. Because my screen wouldn't render, well, won't render the right coordinates anymore, right? If I do this. So yeah. So anyway, we have this. And yeah, we have implement slash add uniforms for chunks for pickup. Slash, I guess that's fine, maybe. Okay, and I wanted to check something. Well, I wanted to rate it. Infinite depth and yeah, for myself. Um, we could support infinite coordinates by I'm not sure about that though. Basically by by having chunks, well, by turn chunks into nodes with collisions to neighbors. Well, we could support no, and then basically that leads to non-Euclidean worlds easier to make. A lot easier to make. Yeah, a lot easier to make actually. That's a good point. Then we have non-Euclidean worlds. Okay. Yep. I just realized something a bit bad. Maybe that's fine. Not really. I don't know. Anyway, we could do that. And that would also, like, basically how would generation look like? That's like a question I'm asking myself. It would be a bit interesting, but I'm not really sure. And yeah, basically I want make a class space that's chunks and chunk spaces inherit from to have hierarchical hierarchy. Well, to have a hierarchy, to have a hierarchy, and basically make it able to scale well, and make the parents able to generate well to pre-generate a large world around the player. Well, around, right? Around. Like, for example, we have mountains in the distance, etc. Right? Basically, that's it. Well, mountains in the distance, biomes, etc. Yeah, biomes, I guess. Was thinking about that. But yeah, I have so much to do. I mean, at least, like, this should be... Yeah, this should have been finished tonight. But yeah, it's not. But it should be, like, easy to destroy enemies after that, though. That's the good thing. That's definitely the good thing. Hmm. Let me just think. Yeah. Yeah, I mean, definitely. Yeah, definitely. Anyways. Music is getting a bit loud to say goodbye. It wants me to go. It wants to replace me. And I mean, I'll be going. That was fun. We have a lot to. Well, we basically also have to regenerate collisions when a block is destroyed. And basically, like maybe 2 days. Like, well, maybe tomorrow I won't really be here, so I'm not sure about this. But 1 day for that, maximum. Well, if we count the debug, maybe. And 1 day for that. And that should be fine. I mean, it shouldn't even be that long, but yeah. And I'm just thinking about this, about having graphs instead of a world, you could say. Yeah, I'm not sure about it. I feel like right now I'm also a bit too afraid to place spaces on their own, but I want cars and that kind of stuff in the future, right? So yeah, I'm not sure about that. I mean, maybe I do want to, maybe I do need to make enemies. Oh wait, I do have to push my readme actually. Yeah, let me just copy this maybe. Okay. Let me open cmd git log, oh, git status. Okay, I just added. So now I'm gonna bring it back. Okay. And now I just want to commit this. Changelog updated. Okay. So a few things. We have cubes. I'm still so far away from the generation. That takes so much time. I didn't think it would take so much time. The pickup was definitely very long. And that's like basically the first time I'm trying to get like some kind of architecture with it too. So I guess that's why it took me like a lot of time to think about it. And like the bits to the compression took me some time. But it should get like more interesting in a few days. We should start getting a game. And I do want infinite death. That's gonna be complicated though. Atmosphere, yeah, visuals, procedural generation. I'm not sure about how I'm gonna do the procedural generation, honestly. Berlin and simplex, yeah, I know. Create vast deterministic worlds based on a random numerical seed, I know. How does it remember? Um, generated by taking 3D noise and carving out air, as the noise value is below a certain threshold. I did via scattering algorithms that check if a location fits the biome's requirements. Disparate noise maps decide if a region is a desert. No. Continentalness. Another layer determines landmass versus ocean placement. Oh, fractal brown. Yeah. Multiple octaves of... Yeah. Yeah, normal. Self pure randomness. Minecraft uses Perlin noise. And now mostly it's simplex. Oh, they switched. Simplex, okay. To generate pseudo-random smooth continuous now. Built a tree algorithm. Fractal terrains. So we have this. That's Perlin. Okay. Yeah, that's Perlin. You can see that it's like there are squares. Squares. Octaves. Little things. Okay. Yeah, I mean, I know what this is about. Yeah, that sucks. I mean, it's just Perlin. Right. It's just Perlin. I wish I can make something a bit better than Perlin. Because the problem with Perlin is that it's random, right? I mean, it's good that it's random, but I really want like specific things, like maybe, like, well, you know, with like, if you have mountains, then that can stop some clouds, and that means it's gonna rain on one side, and you have rainforest, and you have on the other side a desert, that kind of thing, right? So I'm not really sure about this, and I guess I kind of want my own ecosystem and stuff, so that's why. But if I'm not sure. I mean, I do want to, let's say, make something myself, to place some things myself, maybe. But yeah. I'm gonna have to think about it. Anyways, thank you a lot, everyone. And we'll be going. Oh. No. Oh, 2. Yeah. Like that. And wait, I don't have. Oh, what? Yeah. Who's that? Well. Bye bye, people.